There are two versions of IP that currently coexist in the global internet. IP version 4, IP version 4 and IP version 6. IP addresses are made up of binary values and drive the routing of all data over the internet. IPv4 addresses are 32-bit long and IPv4 version 6 addresses 128-bit long. The main reason IPv6 was developed was to provide a solution for the eventual exhaustion of addresses in IPv4. Unlike its predecessor, IPv6 uses 4 times more bits to address devices on the internet. IPv6 or Internet Protocol version 6 is a network layer that allows communication to take place over the internet. IPv6 was designed by Internet Engineering Task Force (IETF) in December 1998 with the purpose of superseding the IPv4 due to the global exponentially growing internet users. The mobility features allows hosts such as mobile devices to remain connected to the same IP addresses even when roaming in different locations. This is made possible by taking advantages of IP addresses, automatically IP configuration, and extension of headers. Faster forwarding or routing for IP version 6. This features a streamlined header that places all extra information at the end. The information in the front part of the header is enough for quick routing decisions, which makes the routing decision making process as fast as looking at the mandatory header section. Version of IP addresses, IPv4. It is the first version of the Internet Protocol address, and the address size of the IPv4 is 32-bit number. In this Internet Protocol, security with respect to network security is optional. It is having 4,029,049,067,296 number of addresses. Still, we are seeing a shortage in network addresses as the use of network and virtual devices are increasing rapidly. IPv6. It is the recent version of the Internet Protocol address. The address size of IPv6 is 128-bit number. In this Internet Protocol, security with respect to network security is mandatory. It allows 3.5, 3.4 into 10 to the power 38 unique IP addresses, which seems to be more than sufficient to support trillion of internet devices present now or coming in future. The transition from IPv4 to IPv6 is yet to be realized entirely. With increasing technological advancements and the number of the global IPv4 addresses available is nearly depleted and the need to migrate to IPv6 has become critical. The primary problem with transitioning from IPv6 is that it is not backward compatible with IP version 4. Routing and domain name system problems occur when using an IP version 6 address with a network that only uses IPv4. Security issues. IPv6 offers many more performances improvements than its predecessor. Yet it is still vulnerable. The main security concern in IP version 6 revolve around header manipulation. Attacks can be based on manipulating headers. Users can minimize them by using IP security or IPsec and extension headers. Nevertheless, these solutions do not always work as specific nodes like firewalls can still be overwhelmed. Tool stacking. When using both IPv4 and IPv6, individual security concerns of two protocols can be amplified. Flooding. With the address of IPv6 being 4 times bigger than that of IPv4, it takes much more time to scan it. Due to this, Smurf type attacks can be a problem. Thus, it is recommended to filter out unnecessary traffic. Mobility. The mobility feature in IPv6 exposes it to security concerns, such as spoofing attacks. Network administrators can minimize spoof attacks by implementing special security measures to resolve them before they appear. Types of IP addresses. There are 4 types of IP addresses: public, private, static, and dynamic. While the public and private are indicative of the location of the network, private being used inside a network while the public is used outside of a network. Static and dynamic indicate permanency. A static IP address is one that was manually created as opposed to having been assigned. A static IP address also doesn't change, where a dynamic IP address has been assigned by a DHCP server and it is subject to change. Dynamic IP addresses are the most common type of Internet Protocol addresses. Dynamic IP addresses are only active for a certain amount of time, after which they expire. The computer will either automatically request a new lease or the computer may receive a new IP address. Different type of IP addresses. Consumer IP addresses. These are the IP addresses of individuals and businesses who use the internet. Consumer IP addresses could be either public or private addresses. Typically, device use private IP addresses within a network and public IP addresses outside a network. For example, each device within the same network is assigned a unique private IP address, whereas a public IP can be accessed directly over the internet and is assigned to your network router by your ISP. Public IP addresses come in two types: dynamic IP addresses and static IP addresses. Public IP addresses. A public IP address is an Internet Protocol address encrypted by various server or devices. That's when you connect these devices with your internet connection. Some even call in their external IP address. A public internet protocol address is an internet protocol address accessed over the internet, like the postal address used to deliver mail to your home. The public internet protocol address is different: international internet protocol address assigned to a computer device. The web server, email server, and any server device that has direct access to the internet are those who will enter the public IP address. Private IP address. Everything that connects to your home network has a private IP address. With the growing Internet of Things, the number of private IP addresses you have at home is likely to increase. Your router needs a way to verify these things separately, and most things need a way to get to know each other. Therefore, your router generates private IP addresses that are unique identifier for each device that separates the network. Dynamic IP addresses. A dynamic IP address refers to an address assigned to a device temporarily by an ISP. Dynamic IP addresses are typically assigned to a device such as computers, smartphone routers, etc. They provide a level of anonymity and security as the private IP addresses or dynamic IP addresses changes periodically, making it more difficult to track a specific device or users. When a device connects to the ISP's network, it is assigned an available IP addresses from a pool. This address is then borrowed for a specific duration before being returned to the pool and assigned to another device. Static IP addresses. A static IP addresses is a fixed addresses assigned to a device that remains constant. They are typically used for hosting websites or running servers. By having IP addresses, users can easily connect domain names to their servers, ensuring that their website or services are always accessible. Static addresses are manually configured either on the device itself or by the network administrator. Static IP addresses are typically provided by the user's ISP or network admin and typically come at an additional cost. Types of website IP addresses. Website IP addresses is of two types: dedicated IP addresses and shared IP address. Let's discuss the two. Dedicated IP address. A dedicated IP address is one that is unique for each website. This address is not used by any other domain. A dedicated IP address is beneficial in many ways. It provides increased speed when the traffic load is high and brings in increased security. But dedicated IPs are costly as compared to the shared IPs. Shared IP address. A shared IP address is one that is not unique. It is shared between the multiple domains. A shared IP address is enough for most users because common configuration don't require a dedicated IP address. IP address classification based on operational characteristics. According to operational characteristics, IP address is classified as follows. Broadcast addressing. The term broadcast means to transmit audio or video over a network. A broadcast packet is sent to all users of a local network at once. They do not have to be explicitly named as recipients. The users of a network can open the data packets and then interpret the information, carry out the instructions of discard it. This service is available in IP version 4. The IP address commonly used for broadcasting is 255.255.255.255. Unicast addressing. This address identifies a unique node on the network. Unicast is nothing but one-to-one data transmission from one point in the network to another. It is the most common form of IP addressing. This method can be used for both sending and receiving data. It is available in IPv4 and IPv6. Multicast IP addresses. These IP addresses mainly helps to establish one-to-many communication. Multicast IP routing protocols are used to distribute data to multiple recipients. The class D addresses 224.0.0.0 to 239.255.255.255 define the multicast group. Anycast addressing In any cast addressing the data, a packet is not transmitted to all the receivers on the network. When a data packet is allocated to an anycast address, it is delivered to the closest interface that has this anycast address. An IP address consists of four numbers. Each number contains 1 to 3 digits with a single dot, separates each number or set of digits. IP address is divided into two parts, prefix and suffix. The prefix part of IP addresses identifies the physical network to which the computer is attached. Prefix is also known as a network address. Suffix. The suffix part identifies the individual computer on the network. The suffix is also known as the host address. How does the IP address work? IP address works in an IP network like a postal address. For example, a postal address combines two addresses, address on your area or your house address. The address on your area is a group address of all houses that belong to a specific area. The house address is the unique address of your homes in that area. Here, your area is represented by a pin code number. In this example, the network address comprises all hosts which belongs to a specific network. The host address is the unique address of a particular host in that network. IP address classes. Class A, B, C, D, E. Class A network. This IP address class is used when there are large number of hosts. In a class A type of network, the first 8 bits, also called the first octet, identify the network and the remaining half 24 bits for the host into the network. An example of class A address is 102.168.212.226. Here, 102 helps you identify the network and 168.2.212.226 identify the host. Class A addresses 127.0.0.0 to 127.255.255.255 cannot be used and is reserved for loopback and diagnostic functions. Class B network. In Class B IP address, the binary address start with 10. In this IP address, the class decimal number that can be between 128 to 191. The number 127 is reserved for loopback, which is used for internal testing on the local machine. The first 16 bits, known as 2 octets, help you identify the network. The other remaining 16 bits indicate the host within the network. An example of Class B IP addresses is 168.212.226.204, where 168.212 identifies the network and 226.204 helps you identify the hub network, the heck host. Class C network. Class C is a type of IP address that is used for the small network. In this class, 3 octets are used to indent to indicate the network. This IP ranges between 192 to 223. In this type of network addressing method, the first two bits are set to be 1 and the third bit is set to 0, which makes the first 24 bits of the address them and the remaining bit as the host address. Mostly local area network use class C IP address to connect with the network. Example for a class C IP address is 192.168.178.1. Class D network. Class D address are used for multicasting applications. Class D is never used for regular networking operation. This class addresses the first three bits set to 1 and their fourth bit set to use for 0. Class D addresses are 32-bit network addresses. All the values within the range are used to identify a multicast group uniquely. Therefore, there is no requirement to extract the host address from the IP addresses. So class D doesn't have any subnet mask. Example of class D IP address 227.21.6.173. Class E network. Class E IP address is defined by including the starting phone network address bits as 1, which allows you to incorporate addresses from 240.0.0.02, 255.255.255.255. However, E class is reserved and its uses is never defined. Therefore, many network implementation discard these addresses as undefined or illegal. Example of class E IP address 243.164.89.28. Rules of assigning network ID. The network ID will be assigned based on the below given rules. The network ID cannot start with 127 because 127 belongs to class A address and is reserved for internal loopback functions. All bits of a network ID set to 1 are reserved for use as an IP broadcast address and cannot be used. All bits of network ID are set to 0. They are used to denote a particular host on the local network and should not be routed.